All right, so today we're going to be talking about air pressure, and here's our atmosphere right here, and you can see the top of the atmosphere up here, and the whole idea here is that there's all the weight of this air on your shoulders, and I'm going to have a guest helping me out today. This is Jordan. Say hi, Jordan.
Hello.
All right. As usual, remember that red slides mean you have to take notes. You should have your Inner Planets handout to go along with this, and don't forget to look for the owl. At the end, make sure you tell me where the owl is and summarize what you've learned in a few sentences. All right, so let's talk about what causes weather. All right, so first of all, my guest here, Jordan, is going to help me read the red slide. So go ahead, Jordan.
Air pressure drives the wind and creates the weather.
Awesome.
The sun heats the earth and air unevenly.
All right, so this is a really important point here, this idea that the sun heats up the earth unevenly. It heats up the earth more in some places than in other places. You can see here that the earth, on a large scale, the sun heats the earth up more at the equator and less at the poles. So that's one example of that. Another example is day and night. The sun heats the earth up on the day side, and it doesn't heat the earth up on the night side. Another example is the difference between like a hot street and the cool lawn, something like that. Another example is the water and the sand at the beach. So when you go to the beach and the sand is really hot, but the water is cool. That's another example of the sun heating the earth up unevenly. So in order to really understand this, we have to kind of understand the idea of what the difference is between hot air and cold air. So we have cold air over here, and you can see that the atoms that make up the air are kind of more closely packed together. They are more dense. And with the hot air over here, the air molecules are more spread apart, so it's less dense. And if you remember when we talked about density and things like that, less dense things will sort of float to the surface, and more dense things will sink. So this air is going to be kind of sinking and heavier air because it's more dense. And the hot air is going to be lighter and move upward and kind of float up because it's less dense and less heavy. So
Warm air rises, cool air sinks.
cool. And
Warm is low pressure, cold is high pressure.
good. So we have to remember this idea that, first of all, warm air rises, cold air sinks, and that warm air goes with low pressure. So we want to kind of put these things together. We want to put together warm air, low pressure air, and rising air, and also cold air, high pressure, and sinking. Okay.
Air, wind moves from high pressure to low pressure.
Cool. So this is basically what causes wind to happen, is that air is going to always want to move from high pressure to low pressure. So you can think of this like when you have an inflated balloon and you kind of open up the little neck part and all the air comes rushing out. And so think of it like this. In the balloon, because the balloon is kind of squeezing in on all that air, there's a lot of pressure in there. So if you let go of this, all of the air is going to rush from this higher pressure area over here to the lower pressure outside part. So we have a high pressure here area where the balloon is and low pressure where this girl's face is, and I apologize to this girl for drawing all over her face.
This circular movement of air is called a convection current.
Exactly, right. So this is called convection. We've talked about convection. Convection comes up in this class quite a bit, but this is basically the idea that you have warm rising air and cold sinking air, and it goes in sort of a circular kind of pattern, just like this over here. And this is basically the reason why you have the high pressure area moving towards the low pressure area, because as this warm air rises, it kind of leaves an empty space right in here. So that cold sinking air has to move over here to fill it up. But when this cold air sinks, it kind of leaves an open space up here where the Warm rising air moves over here to fill in that space.
Air pressure, the pressure caused by the weight of the atmosphere.
Cool. So when we think of the atmosphere, I know a lot of times when we think about the air, we think of it as kind of nothing, like there's nothing in between you and your phone right now or you and your computer right now. But there is stuff there. It's air, and air is it's stuff, and stuff weighs something. So all of that air kind of weighs down on your shoulders. Now, when we're down here near the Earth, all of this air here has all of this air on top of it. So it's getting squished like a sponge. And that's why this air is much more dense down here, like this part. When you're way up here, the air doesn't have as much stuff on it, so it is less dense.
As elevation increases, air pressure decreases.
Right, so draw this in your notes, draw some spread out dots near the top and make them get more and more packed together as you get towards the bottom. All right, so what this means basically is that when we're down here near the ground, here's you. It's not a very good drawing of you, but that's you. Down near the ground there, you have all of the weight of all this air on top of you here. So you have the weight of all this. But if you were to, say, climb up a mountain like this, and you were to go up here on top of the mountain, there you are, on top of the mountain, now you only have this much air on top of you. So as you go up in the atmosphere, the air pressure decreases just because you don't have as much air on top of you. So
Low pressure,
that's at the top of the mountain, and
higher pressure.
higher pressure is at the bottom of the mountain.
Barometer, instrument that measures air pressure.
Cool. So we've been using these in class. You should probably know this by now, but that is the instrument that we use to measure air pressure. And we also call it barometric pressure because we use a barometer to measure it. We have a few different kinds. That one is called an aneroid barometer. I know that's kind of a hard word. That one.
Mercury.
Yep. And that one.
Water.
Cool.
High pressure equals good weather.
Okay, so we want to kind of keep this idea in mind that high pressure is going to lead to good weather. And really the barometric pressure, the air pressure, is pretty much the best indicator to tell you what the weather is coming up, to make your weather forecast. So if you have high pressure, you're going to have good weather. And if the pressure is rising, that means we're going to have good pressure, good weather tomorrow. But on the other hand,
low pressure equals poor weather coming.
Yeah, so if we have low pressure now, or if we have a decreasing pressure, that means that we're going to have more bad weather coming. And when I say bad weather, I really mean like cloudy and rainy. Don't really think of temperature here so much. It's just sunny versus cloudy and rainy. Now, the question is, why does this happen? Why is it that low pressure leads to bad weather and high pressure leads to good weather? Well, it all has to do with this idea of convection and the fact that high pressure air is sinking and low pressure air is rising. So we need to kind of see what happens when that low pressure air rises. So in that animation, what you could really clearly see here is all this rising where the clouds are, and you can see the water starting to condense as the clouds form. We'll talk more about how clouds form later, but that's the basic idea. When the air rises as it rises, the water in the air starts to condense and form these clouds. So over in this area, you have a low pressure system. And over here, where it's clear, you would have sinking air over here and a high pressure system. So in general, the air is kind of, remember, it moves from high to low. So it's moving kind of over this way. It's getting heated up and it's rising. And then it's moving over this way, cooling down and sinking again, and we get our convection cell here. So here's a question for you. You have this question in your notes. What causes the wind and weather? Make sure you do a good job of answering that question, and I'll be checking that in class. All right, so what we learned today is that air pressure drives the wind and creates the weather. The sun heats the earth and air unevenly. That's kind of the starting point. Warm air rises, cold air sinks. That's convection. Warm is low pressure, cold is high pressure. Air or wind moves from high pressure to low pressure. As elevation increases, air pressure decreases. A barometer is the instrument that we use to measure all this stuff. And high pressure equals good weather, low pressure equals bad weather. And thank you very much to my guest contributor, Jordan. See you, Jordan.
All right.